All right, so we're starting with what is the inverse of f of x equals x plus 1 over x minus 1. Set it equal to y. And a moment ago, I said, what do we do? And the correct response was we switch x's and y's. Okay, conversation from inverses. We also knew that it was symmetric over the line y equals x. And if I was given the point 2, 0, I would have the point 0, 2 kind of deal. We'll usually talk about more than one point, but lots of y's. I don't want so many y's. Going to multiply both sides by y minus 1. So far, so good. Y plus 1 equals xy minus x. Going to get the two y terms on one side. Going to subtract xy. I'm going to subtract that 1. Factor out a y, 1 minus x, and divide. Y equals negative x minus 1 over 1 minus x. And that is the inverse. So if I put a number in for x here and I'd get the y, remember if I take that value and put it in here, I'd go back to where that x was. I'd go back to where I started. Questions on doing that? Questions. That's one of the harder ones, but the concept is going to be in Math 103. The concept is going to be in Math 104. The concept's going to continue on in other math classes. So what is an inverse? Once I know how to do it, there's lots of stuff later on that you'll be able to do with it. Okay. Picking up where we left off the other day. Way back when we had y equals 4 plus 2x. This is just going back to how I remember 4, 1, 2, 3, 4. I go over 1, I go up 2, and I keep adding 2. Okay, I call this the initial value, and it's repetitive addition. And then we went to these things the other day. 3 times 5 to the x. My initial value again is at 3. Okay, in the algebra world, we call that for the y-intercept. In applications and word problems, we call it the initial value. So this guy is always going to be the, and then when I take 1, it would be like multiplying it by 5, then multiply it by another 5. And we got some kind of graph that took off like crazy. If I put in -1, which I can, I would get 3/5. So it's having a good time. And we talked about these things and an exponential graph, and basically an exponential graph had the look of this kind of deal where it came down and hit my asymptote. Got the idea? And again, this was exponents. Exponent. Well, if I took the idea of inverses, combine it with the idea of exponents, I might then start talking about, ooh, what is the inverse of an exponential function? And it would look something that looks, oh boy, it would be something that looks like that. Okay, it's the inverse of it. It's the idea that if I put a value in here, like 3, up here, if x is 3, what is y?
Two.
2, yeah. So if I swapped it and came down here and said, hey, this time, if x is 2, what do I get out of that? I get a y value of
1/2.
Let's see what we got. -2 minus 1 is -3 over unless we did did this wrong. If I put in negative
-3.
-3 over -1, which is +3. It is in fact +3. So when I keep this idea here with the exponent, you know, and if I said, okay, yeah, okay, good. If I put in a value for x and said, oh, what if x is 2? We'd get y equals 5 squared is 25 times 75. So what I need to now talk about today is if I have an exponent, what is its inverse? Well, I know what it's going to look like. It's this red line, but I need a way to put in 75 and get out 2. Okay, what is the inverse of an exponent? I'm glad you asked, because the inverse of an exponent is this bad boy called logarithmic function. It's a logarithmic function. So the inverse of an exponential function is a log, and backwards. Go one way for the other, one way, the other. Okay, so let's see. I start out with something that looks like this. I have, oh boy. Yeah, okay. So we're going to have something called a log function, and a log is something that looks like this. Y equals log base b of x. Now, why did I say base b? Because when you look over here, the bases become it's going to be the b. Okay. So this guy, y equals log b of x, can be rewritten as the base b to the y power equals x. Okay. Base to the opposite side equals x. So if I start looking at some of these, base to the opposite side equals x. 4 squared equals 16. It's another way of rewriting this. 5 to the -1 equals 0.2, which is 2/10, which is 1/5. You know, these both are 1/5. This guy, base 8 to the 0 power equals 1. Yeah, we kind of know that as a fact. We know that as a fact. So we're getting a brief introduction here of these things called logs. And then in a little bit, we're going to see how they compare to exponents. 23, base 23 to the 0 power equals 1. All of these are true statements. Okay, here it's written in logarithmic form. Write each equation in exponential form. I wanted to point that out because one of the things on the last test that some folks had trouble with was they weren't really getting the instructions the way they should have been getting the instructions. Would have helped in solving the problem. All right, let's see what we have here. Write each equation in log form. Log, here's my base, right? 2 of 16 equals 4. Just practice going back and forth. My base is 27. Log base 27 of 3 equals 1/3. Eventually, we're going to be putting variables in here, unknowns, trying to solve them. Log of 1/4, base 1/4 of 16 equals -2. All right, so let's step it up a little bit, evaluate log expressions. This equals x, right? If these are equal to x, what is it? What is x? Well, I'm going to take this log form and I'm going to rewrite it. 12 to the x power equals 144. I'll help you with that one. That one is 2. Participants. Do the next 2 real quick. Abby's here. Good morning, Abigail. She must be mad at me. She's not talking. Olivia is here. Good morning, Olivia. Hope, you're not here, are you? Kaylee's not here. Hope is not here. Jandy is not here. Come on, man, if I can get up at 8 o'clock. Anyone get an answer for the next one? 64 to the x power equals 8.
X equals 2.
Be real careful. You're squaring the 8, not the 6. Yeah. I'm going to go the other way. X equals 1/2. 64 to the 1/2. That's the same as the square root of 64. Because I wanted the square root of that to get 8. Good, wrong answer, Nina. If there is such a thing. You see the difference where it caught you. You saw 8, you saw 64, you thought squared. It was actually going the other way. All right. 3 to the x equals 1/27. I may have to do a little work here. This is the same as 1/3 cubed. This is the same as 3 to the -3rd power. I get x equals -3. What you think about that? Okay, so logs are great, but down here at the bottom, you also see 2 special logs. And a lot of you had algebra 2, pre-calc, and maybe even calc in high school. Forgot some of it, but we have a log, and if the base is 10, I can exclude the base. This is called the common log. And the other day we talked about this letter E, 2.718, blah, 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 blah. Log base E is also written as ln, which stands for natural log. So we have the common log, no base, the natural log. That's base E. Okay, good. 11 through 14. 11 through 14. Solve. Evaluate. That's a different word. So this again is really log base 10 of 100 equals x. 10 to the x equals 100. I get x equals 2 for that one. Oh, oh. Equals x. 10 to the x equals 10, 100, thousands, 10,000. 1/10,000. 10 to the x equals, that's 10 to the 10. 10 squared is 100. 10 cubed is 1,000. 10 to the 4th. And of course, if I rewrite that, it becomes 10 to the -4th. X equals -4. I am not promoting much student involvement at this point. So get ready, because you're going to become involved. Oh boy. This becomes log base e of e to the negative 3 equals x. E to the x equals e to the negative 3. I get x equals negative 3 here. The natural log is log base e. So log base e of e to the negative 3. If I change it to an exponent, e to the x equals e to the negative 3. Pretty simple so far as you're doing them. First looked at them, you're probably like, what? What the what? 14, what does it equal? I'm going to wait you out on this one.
10.
10. Very good. 10. Okay. So not all logs can be done with changing them from logs to exponents. Okay. That's what we've done. We've changed a logarithmic form to an exponential form. Okay. Not all of them can be done. And as you can see by the directions here, use the calculator. All right. So I want log of 200. I'm going to turn this on and let's see, I want to clear all that. I need to find where log is. And nice, there it is. Now that log is log base 10, which is what this guy is. Right below it is the natural log. So if I want the log 200, I don't have to do anything in my settings. 2.301. 2.301. Log of 0.074. Log of 0.074. Oh, negative 1.131. Not so bad. Kind of not afraid of logs. I'm easing into this. Natural log, 200. Yeah, 5.298. Finally, natural log of 1.005. 1.005. Easy peasy. 0.005. We'll go with that. Okay, so sometimes we do have to, in fact, go to the calculator. Fortunately, it's pretty easy for us. Questions up to this point? Okay, so what do we have now? Basic properties of logs. And if I look at this, it kind of makes sense. B to the 0 equals 1. B to the bx equals x, because b to the x equals bx. B to the first equals b. And this guy just looks like a mess. But if I look over here, b to that guy equals my x. So a couple of simple rules. You don't need any of those. You can continue to do them like we were doing on the last page. Set it equal to x and go to town. So I'm going to pause right now. Okay, there's the 9 answers. Hopefully you found some of them to be easy. I want you to put in the chat how many you got right. Out of 9. Nine out of 9. Very good, Kaylin. Ella got 8. Nina got 4. Olivia 7. That's 4 people. There's 14 here today. There's a 7 and a 5. Okay. Numbers are still coming in. There's another 7 and a 6. Okay. Let's see what's going on here. You know, if this was log base 19 of 19 equals x, I would be saying 19, that's my base, to the x power equals 19, which is the first, x equals 1. And then that would be the same here. This is common log. 10 to the what power equals 10. It's 1. Here's e. E to the first power equals e. So all of those end up being the same. They all equal 1 if the base is equal to the number after the log. All right, if I'm looking at this one, log of 273 of 1 equals what? 273 to the what power equals 1. And anything to the 0 power is going to give me 1. So anytime that's a 1 in there, they're all going to be 0. So that's 22 and 23. This guy, if I set it equal to x, I'd have 30 to the x equals 30 to the 10. So x would equal 10. And again, you don't have to memorize these rules. You can just do what we've been doing. Just like 34, we have 35. Remember, this is log base e of e to the negative 12 equals what? E to the x, that's my base, equals what's here? E to the negative 12. X would equal negative 12. This guy is an exponential to start. So I rewrote it as log base 10 of x equals log of 14. Well, this is the common log and this is the common log. X equaled 14. Same here. Base is 8. Log base 8 of x equals that x, log base 8 of 5, x equals 5. Okay, going back and forth between logs and exponents. Questions? Hopefully those of you that didn't get certain ones, that helped. Oh boy. So I talked a moment ago about inverses, okay? And basically what I said was, if I had to take a look at the graph of y equals 1 times 3 to the x, okay, I know it crosses at 1. When I put 1 in, I'd get 1 times 3 and so forth. And it would grow exponentially. Now, these tick marks are different, but here's what the graph of a log looks like. And we've mentioned this a little bit ago. So the inverse of this is going to be log base 3 of x. That's what this graph is. Okay. And again, I could sit and give you numbers and you're going to go like, okay, if I get x values, you know, what is log? Oh boy, if I said x equals 0, what is log base 3 of 1? Well, I could go through and solve it. 3 to the y equals 1, y equals,
That'd be 0.
would be 0, right? So I need to back up here. I put in 1 instead of 0, so it would end up really confusing you. Let me back this up. I want to say it a little bit clear, okay? If I said log base 3 of 0, that's my x value, equals y. 3 to the y equals 0. Well, guess what? I don't have a 0 because there's nothing to the y power that would give me 0. That would mean I have an asymptote right there. So this would be an asymptote. Okay. Now, if I said, okay, let's do another one. This time, let's let x equal 3. and I did log base 3 of 3 equals y, okay? 3 to the y equals 3, I would get y equals 1. If I come over to 3, you see the point 3, 1. And I could keep going like that. I would pick certain points. I would pick a point like 9. Log base 3 of 9 equals y. Again, my x value, 3 to the y equals 9. Y would equal 2. If I come over here to 9, you can see I'm up at 2. So that's what the graph of this looks like. Again, I put in 0, I got no, it's my asymptote. It's going to be really similar to, well, it's the inverse of an exponent, which was the other way. Wah, 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 wah. We're not going to do much with this, but this basically says, hey, now, this is y equals log base 2 of, watch this, x minus -1 plus 2. Remember when I affected my x right away? Yeah, I remember. Y equals a, and then, for example, I did x squared, x minus h squared plus k. I can do the same thing. Instead of my function being squared, this time it's log base 2. So once I graph log base 2, I would be shifting it to the
Left.
yeah, my left one. So now instead of my asymptote being at 0, I'd have an asymptote there. And then I would also shift it
Up.
up 2. Very good. Left 1, up 2. Okay, same kind of thing applies. And there's a little bit of a discussion down here about how it uses the same form as we saw before. The H is left and right, the K is up and down, and the A, oh boy, that makes it wider or skinnier, or it changes my values by a multiple. All right, earlier we talked about inverses. Here it is again. There's my line, y equals x. You see an exponent, y equals b to the x. You see a logarithmic, y equals log base b of x. And how they are similar, just inverted. Give the domain and range for this guy. Well, I'm thinking that it's there's that, so I'm guessing there's an asymptote over here at 1, 2, 3, at -3. So the domain is going to be x is greater than -3. Range is going to be all real numbers because it goes all the way down, and my y values go up, even though they're still constantly growing. They're going on and on and on. Sorry. I throw my hands up in the domain. Well, that's not so pretty, but this is pretty. Looks like I have x values greater than 0 because I'd have some kind of asymptote there. And again, the range is going to be all real numbers. Not something you're going to deal with very much. This fella right here, you're not going to see it. But what's the domain? Looks like it starts at -infinity and goes all the way up. And it looks like it's going to go to 0, but not include 0. Union with, looks like it's going to have another asymptote there, 2 to +infinity. Domain, no, domain. Range looks like -infinity These guys go down to negative infinity. Looks like they're going to come up and be cut off at 2. So I have something that looks like that. Ooh, can I get a ooh? Ah. This scares me. Look at all those words. The absolute magnitude m of a star is the apparent magnitude m a star would have placed 10 parsecs from Earth. Huh. The absolute magnitude m of a star is the apparent magnitude m if a star would have placed 10 parsecs from, okay. The lower the value of the magnitude, the brighter the star, okay? Our sun has an apparent magnitude of negative 26.74. The brightest star in our night sky is Sirius, the dog star. Apparent magnitude, okay, I'm all right. So the lower formula. Relate a star's absolute magnitude, apparent magnitude, and distance from, okay, so there I have the distance is d. Distance is d. That seems important. I have the absolute magnitude, which is m, and I have the apparent magnitude, which is little m. Let's make this bad boy bigger. Big M. If Sirius is 2.637 parsecs from Earth, and the sun is blah, blah, blah parsecs from Earth, what is the absolute magnitude of each star? All right, well, let's do Sirius. And Sirius has a distance of 2.637 parsecs. That's D, right? The sun, tell me if I'm right or not. Our sun is an apparent magnitude of 26 point, an apparent magnitude is little m. Sirius has a distance of D. So coming back up here, I have this as well. Little m for Sirius is negative 26.74. The sun, oh boy, 4.887 times 10 to the negative 6 parsecs. And its apparent magnitude was negative 1.44. I need to find big M for both of those. Oh boy. Seriously. Get it? Serious. Big M equals little m for Sirius, negative 26.74 minus 5 log 2.637 over 10. Help me, Rhonda. So I have this crazy equation that they came up with. I have an absolute magnitude of m. I have an apparent magnitude of little m. I have a distance of d. Okay. I know that our sun's apparent magnitude, that's the little m, it's negative 26.47. And I know that the brightest is, so that has, do I have these two backwards or something? Oh, that's negative 1.44, not a 7, just to be careful with that. Okay. Somebody get an answer for Sirius's absolute magnitude.
I think you do have the apparent magnitudes backwards.
Backwards. I'm sorry. Our sun has little m of negative 20. You are correct. This little m is negative 26.74. Sirius's little m is negative 1.44. So that's going to change this equation. Thank you. Negative 1.44 minus 5 log 2.637 over 10. It's good I reread it. I think y'all are sitting there waiting for me to do it. First thing I'm going to do is say, what is it? Well, that's not so bad. Negative 1.44 minus 5 log of, to divide by 10, 0.2637. I'm going to take the log of that. The log of 0.2637, and I get a value. Now I'm going to take negative 1.44 minus 5 times, and I'm going to hit second negative sign to get that previous answer. Negative 1.44 minus 5 times that previous answer. I get the value of 1.454. Okay. The lower the value of magnitude, the brighter the star. So let's see who's brighter. There's Sirius's magnitude. Lower is better. Let's check out the sun. M equals little m for our sun. Now we have negative 26.74 minus 5 log of, oh boy, that means I'm moving my decimal place 6 to the left. So it's going to be, I have that 4887, and I'm going to move it 1, 2, 3, 4, 5, 6 times. 0.00004887 divided by 10. Oh boy, it's going to move it another one. 0.12345648887. Everybody's with me on that? Remembering working with things like 4.887 times 10 to the negative 6. I'm going to take the log of that mess, the log of 0.12345648887. Got an answer. Now I'm going to take negative 26.74, and I'm going to subtract 5 times the log of, I want my answer from the last line. Oh, where did I mess up? Negative 26.74 minus 5 times the log of that last answer. It doesn't like it. It says it's, well, let me see if let me double check the log again. Log of 0.12345648887. I got a negative number. All right, folks, did I mess up somewhere? Negative 6, that makes it smaller. Divided by 10 makes it really small. The log of all of that becomes a negative number. Now I'm okay. I just did the log of that. So now I'm going to take negative 26.74 minus 5 times that answer. There we go. I get 4.815. Can anybody else get that?
I have a question.
Yeah, did I mess up again?
So you'd subtract 5 from those first ones, not multiply the log by -5?
Well, so when I put it into my calculator, you see I did negative 26.74 minus 5 times the answer. Order of operations will automatically multiply those two first and then do the work after that.
But but the calculator's not.
Okay, so let's,
Like-
yeah, okay, let's do this. I'm gonna do I'm gonna do it this way. Log of 0.12345648887, and I got an answer, okay? Now I'm gonna take 5 times my answer. Okay? Now, from there, I'm gonna go negative 26.74 minus that last answer, which was 5 times that log, and I still get the 4.815. So it is actually doing the multiplication first. I did the log, multiplied it by 5, and then took negative 26.74 minus that answer, which was negative 31 point blah, 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 blah. Does that help?
Is the answer
Yeah.
negative or positive?
The answer I have is 4.815. The dog star is 1.454. So the lower number, it looks like the dog star is brighter than the sun.
How did the answer become positive? Because we have negative 26 and negative log of that, it is still
Okay.
negative.
So when I did the log of all of that, it gave me the number -6.
Yes,
So I now had negative 26.74 minus
Yeah.
5 times negative 31.
okay, that become
negative
positive.
6.31 da 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 da. So
Mhm.
that made it a positive, and it was bigger than that. Oh,
Yes.
sorry. I'm sorry there. Yeah. Yeah, I know it looks at first like a negative and a negative, my answer better be negative. But because this guy evaluates out as a negative, it turns this
Yes.
into a positive. Yeah. Good question. I like
I was lost.
questions.
Are we gonna get like these questions in exams? No? Okay.
No.